Okay, today we have a Mellerware Luna cordless kettle. Let's check. Model number, just model Luna. 2200 watt. It doesn't work. It's plugged in. No light. And I know this neon light has been giving some trouble, but I mean it doesn't get warm as well. So how this works is the connectors, the power comes in here on the base. Let me just plug it out. Power comes in here on the base. I'll have to check what is what, but it seems like there's 3 points, and I would assume this outside one is the earth, and then the middle ring is either neutral or live, and then the center ring is either neutral or live. If we turn this kettle around, we see here, put it down, here are the 3 connectors. The outside ring I assume is earth, and then we will see what is these ones. Let's first open the base and see if there's power coming in towards these points. If you check on the back here, there's a few screws here. There's ones on the inside as well, a bit rusted. I'm going to check which ones it is, and I'll let you know. I just quickly want to show you something here. Now they tried to bugger us with these 2 screws that come in with the cable. They have these triangle points. Now I don't have a screwdriver set with that, but that's a reason why you never throw away your old screwdrivers. I fastened many of the old ones that broke or got blunt. I sharpened them into different shapes to fit different points that I don't have. So for instance, this one, it's not triangle, but it fits in here and it actually turns the screw out. What we can see here is the 3 points. Now the middle one, green and yellow, comes on the middle point. That's the earth. On the left hand side we've got the blue one, which is the neutral, and then the brown one, which is the live. Now if you look closely, put it like this, you can see the live one connects on a point here and it goes to the center. The neutral one connects on the point here, and that is on the middle ring, and the earth is the one that goes directly to this point here. Come on. Okay, so an easy way to test this, to make sure, test first before we get hurt. Put your meter on either the buzzer or the ohm. There's an ohm, which will just give us an ohm reading, or the bell tester that gives us a beep. So what you want to do is, in South Africa, when you look at a plug, on the left hand side is a live, on the right hand side is a neutral, and there's earth on that side. So we put it on the live, and we test the live one here. There you go. So the cable is fine. On the neutral, there you go, that's fine. So there's nothing wrong with the cable. You don't need to test the earth. We can if you want, but I mean the earth is not going to stop this thing from working if the earth wire was broken. So basically what that means is the cable is fine. So either there's something wrong inside the kettle here, or this doesn't make a good enough connection with that. I think our next step will have to be to open up the kettle. Well, unfortunately this is going to be a short video. To open up this bottom, we had to remove these deep screws, 3 of them, and then there's these 3 on the top. Let me show you. This is like this. So there's these 3 screws there, and those 3 ones there, and then this whole thing just comes off. Now we can clearly see the ring here and all the connection points. So what happens when you push the switch up, there's a little switch on the side, copper switch, and there's one here. So it breaks the live and the neutral. And I won't be able to get in underneath there to show you what it looks like, but it's just two small copper plates that acts like a switch. So this is a very, very simple mechanism. All that happens is when the live and neutral comes in here, it goes to that copper side and it's connected to this one here. This would be the neutral and this will be the live. And so it lets power go in to the live and it connects the neutral, and that connects directly to the dry element. Dry element means the element is not touching the water. It's actually underneath the last plate. I'll show you now when I take this out. But anyways, easily enough, that's all. Those two switches on the side get switched when you pull the lever up, and that gets power directly to the element, and then the element heats up. There's two extra wires going onto this side that only gives us power to this little neon bulb here, to 20 volt neon bulb. On close inspection you can see that this point here has started to melt a little bit, either due to a loose connection or just being to the proximity of the element. But anyways, we can check the element, and we put our meter on ohm scale over there. 1.7, 1.8 mega ohm. That is definitely not the correct reading. So unfortunately this element is buggered, and I can promise you now there's no way we will be able to get an element to replace this. And I assume if we probably could, it's not going to be worth it. Just as well buy a new kettle. Okay, so what could have happened, we can quickly work out. Let me just put this in the stand again and we'll work out what the ohm should have been. I just quickly want to show you what dry element means. You see, the element is not on the inside. There's a ridge there, but that's not the element. The element is here on the outside. It doesn't touch the water. Dry element. Some geysers are dry element, some geysers are hot element. Mostly all the geysers was dry element. It was a lot nicer because you didn't need to drain all the water to replace the element on the geyser. Okay, let me quickly show you here what we should have gotten on the ohm reading. We can see here it says on the element 1850 to 2200 watt. So our wattage P equals 2200 watt. Let's work on the worst case scenario. It works on voltage 220 to 240 volts. Our voltage here is about 230 volt. Voltage is 230 volt. Okay, so we want to know what the ohm reading should have been if this element was still working. So what you can do is you can say P equals I times V. Okay, you can get a little triangle here going, and this triangle helps you because you will always know if you want to have P, it's I times V. If you want I, it's P over V. If you want V, it's P over I. Okay. The other one we're going to use is VIR. Okay. So this is one we're going to start with because we know we want R. We want the ohms. R equals V over I. Now, we know the V is, we're working with 230. We don't know what the I is. That's where this one comes in. So we can say I equals P over V. We know P is 2200. We know V is 230. So if we work that out, (9.56) amps. Okay, so now we've got our amps here. I is amps. 9.56. So now we know R is supposed to be 230 divided by 9.56. 24.05 ohms. So if our reading, if we measured here across with our multimeter, and we got anything in the region between even even between 20 and 27 ohm, our element would have been fine. I mean, these manufacturing processes is not an exact science. Sometimes you get out of the same process a 22 ohm element, and sometimes 24, sometimes 26. So if we measured across these 2 points, or those 2 points, anything in this range would have been fine. But it's not. It's in the mega ohm range, so we know the element somewhere is broken and needs to be replaced. If you find this range ohm reading, then it means there's somewhere else a problem, either with maybe this switch here, or the switch on this side here, or the connection between the base and the kettle itself. So that's it. Thanks for watching.